Hello. So in the last tutorial, what we did was we took OpenCV frame and then we packed it into, into serialized data, and then we again deserialized it, which is unpacking the frame, and then we saw whether the video is correct or not. Just for a quick reference, I will play the sample again. Um, if we go in the run, yeah, it will run from terminal. Let's check if everything is working fine. And yeah, so we are getting the video. Now, what we need to do is, yes, we can cover the topic where we need to see whether the frame per second is proper as the video's frame should be. But presently, we can focus on something different. Is that once we have serialized the data, how can we transfer it over the socket and see whether the data comes fine or not? Because that's what the main goal of this tutorial is. So for that, as in the introduction I said, I will be using ZMQ, and specifically with ZMQ, what I will be trying to use here is a CPP ZMQ wrapper. So let me just open up the window. Okay, it's taking a lot of time. Okay, here it is. So CPP ZMQ. So if I look at CPP ZMQ documentation, which we can go at a header only library and other things are there. So this is where you'll find the git repo. It is just a wrapper over ZMQ, and we'll be trying to use this one for our you know our present code. So what we are going to use is a ZMQ has multiple configurations like request, reply request, and then publisher subscriber, router dealer, and other things. But here we will be using publisher subscriber, and with that, since the CMake is already installed on my system, and about all this basic installation, how we do that, and other things we can cover in a separate video where the basic setup for environment I can show, and what are the things which I install on my system for doing developments in OpenCV. So with that said, uh, what we are going to do is change this. This is the same project, and introduce new two classes, as well as two separate executables called as client and server. So let me just give a minute. Okay, so that was a quick break, and what we want to do here is we want to create two separate executables. One is client, and one is should be like a broadcast server, where the OpenCV image is served by that broadcast server, and then on the other side, we receive it and we display it. So for that, let us quickly. So I have already like created. If I once again show the containing folder, so I already added something called as client, ZMQ client.cpp. So we can go ahead and delete it, and we can do it from fresh. So what we do here is close all, and first we'll start with add executable, and here let's name it as just what broad client, simple as that, no complex naming here, and we will have it as client.cpp, and obviously client.h, which we are going to create in a short while. And then we are going to use frame packer, because we need to pack and unpack the frames and these things. So similar thing we can do for our broadcast server. Now these are two things, and what we need to do here is we need to again link libraries, but we need to link libraries as cppzmq2. So for that, this will be here, and if we want to link cppzmq, if we go through the this one what we see is here we have just you need to mention cppzmq over here, which we are going to do. cppzmq. Now what we need to, the main thing which is missing is these two classes. So let's quickly go ahead and add these two classes, and we are going to add new and C++ class, and this will be just client.h client.cpp, so it will be done. And yep, and then okay, here we have given a wrong name, so let's mention this as server, and let's mention this as server. So now we go ahead and what we do is we add another in the frame packer, irrespective of where we are adding frame packer or whatever. Okay, I think that will create confusion to others, so let me quickly change that. CMake is showing error because server.cpp does not exist. That is fine, because we have yet not added server.cpp and server.hpp in the directory. So once we add that, so let's call it what do we call it, server. Okay, so localize that, and now if we do this, I think yeah, all the, if you see the build has been done and it is creating over here. Okay, so that is fine. Now we have here two projects listing in the project layout of this Qt, and we have a server and we have a small client class. Now what we need to do is we need to create basic things here. So what it takes is server takes since we are going to do a local host, so it would be but it would be better that it just takes an address. So std string address, let's take that, and std string, and we also will need obviously the zmq, so zmq.hpp. Now same thing will be going in our as well as the function for clients, but first thing will be void send, so like publish, you can call this function as publish frame, and what it takes is this just takes a std string of data rather than and it actually takes a reference of the data, so the data which it needs to dispatch, because the frame packer will be serializing the data into a string array, into a character array for us, so we just need to pass it, and the publish frame will be taking care of publishing it to the just publishing it, and then the zmq subscribers who are present will just try to take the data and do something with it. Now let's create some private variables which are going to be helpful for this guy to to do the basic operations. So first thing which we will need is any zmq which needs a zmq context, so which we can create like this. So let's name it context, and then we would need socket obviously, so socket would be socket over which the operations would be actually done. Since you are already doing something called as publisher subscriber, so publisher publishes the data over a topic. Topic means like a tag, like okay, so I'm publishing over this and that, so why not take this from the user. So let's have topic name to come from the user, and I think that would be all which we will need for this kind of thing, and that's all. So now we have a server, and we quickly go ahead and start creating the definitions for them. So we have two things over here, and we don't need to create any getter setters for msocket or mcontext, because these are the things which are created by which we will be creating inside the constructor. We need a graceful shutdown, so what we do is we create a destructor so that we can delete stuffs when we are leaving. And okay, so now let's quickly jump into the things like creating the server. So it will go like this. Address would be address. First thing is we need to start providing with the context. So what we need to do is create a context is like consider is like a watcher pointer which we can always refer in a ZMQ to see whether how our socket is, or if we want to close it or do something with it, because means like to have a control over it. So that's what it stores, the context of means the scope. I don't know which word is better for it, but the ownership or the pointer towards the ZMQ entire operation. So we need to create one of that. So ZMQ, and it's like this, and you just pass a number over here. And now if this is done, what we need to do is we have got an address and we have got the topic name. So first thing we need to do is initialize the socket. So the socket is initialized like this, socket D, and you need to give it a context that okay, use this context while uh, creating thing. And then you need to specify what kind of socket you are creating. So I am creating a, see, you can see there are multiple types: pair, publisher, subscriber, pull, push, and other things. So I'm going to do this. And then what you need to do is you need to give socket, just like any TCP socket communication, you need to give it a bind with the address. So the address is directly this. Note that like normally you need to give a port number and other things, but over here I am like just providing the complete address, and it is expected that the address would be provided by the user in a proper way. Otherwise what you can do is not even take this. In fact, let's not mess with that for now. So okay, we change this to this. And why will it be string? Okay, so let it go here. And what we do is we make something like this, very conventional um, what we say, ZMQ example. So what we do is we create here on the fly a proper address for the server to start with. And let's take the port and we create this. And what we need to do is we can check. So you can do this socket dot connected, and means the socket is ready and listening. Now we can do one quick thing is see out. Okay, I'm not using spd log here. What we can do, we can use spd log here, but okay, we will see what to do. See here, enable to start server. Okay, let's use spd log without hesitation, because why not? spd log is much better than anything. So spd log error, enable to start server. Okay, and what we need to do is we can throw from here std runtime error, and we can give the same thing, that because going forward and doing any other operation is just nonsense, because we have not been able to create our socket. So it is not at all good. And we have a deprecated warning, is that warning connected is deprecated, use handle. Yeah, this is something which we can cover in the ZMQ tutorial, where there is a lot of things now coming up via using handles. So okay, but let's go with the conventional sample. So this is all we need to do while creating the server. Now let's jump quickly into to the scenario where you want to send a message. So what we try to do here is just convert the message which we have received into a, it can be a const for better understanding. Okay, let it go. And what we can do is we can just cover it connected also. We don't need to check that much for now. What we can do is start with converting the string which we received into a ZMQ message template, which is so first thing which you need to do is you need to get the topic name. Okay, we didn't capture the topic name into member variable. I think topic goes to topic name. Yeah, so topic name, and if we take the topic name here, and what we try to do is now first initialize them with the size. So the size would be like m topic dot size. So this will create a buffer of ZMQ message t, and same thing, not same thing, but in a different buffer we need to create the data topic, so like the payload or actual data. So what we need to do is ZMQ, not ZMQ, data dot size, and here we have two things created. These are the two buffers we created. Now we need to copy the data, so let's use copy, and what we need to do is we need to convert the m topic data into this one. So topic name dot data, which will point to the buffer which where it needs the data to be copied, and the source location can be from our member variable m topic dot you can have the data, and then you can specify which is will be the beginning pointer of it, and then you can obviously m topic dot size. So here we have all these things ready. Then same thing we will go for our payload. So payload dot data, so it gives us the beginning pointer. Then what it needs is now the beginning pointer of the data, so that is again from this, and then data dot size. So now we have this. Why is it causing the problem? Okay, so these two are done. Now what we need to do is there is something called as send mode. So what send mode, how ZMQ does is, once you first need to send the topic name, like okay, I am sending something. The first thing which I am sending is like I am sending you the topic name over which following will be a trail of data which you will receive. So this is how. So basically what you need to do is first you need to send the topic name. Come on, auto suggest. I'm pretty lazy here. Why do you make me type so much? Okay, send flags none. So not none, you have to do is send more. So it is saying that okay, hold on, there is more data which is coming. So this is like the RC is the return code, and you can obviously do while writing a proper code, and this is just a sample, so you can check whether whether all the returning and all the data which you are trying to send is fine or not. So you need to, it's good that you do a check over this return code. However, for now we need to send the payload, which is again, so the ZMQ wrapper of send consumes directly a ZMQ message t, and now since we have already sent everything, so in this one the send flags will go as none, and that's it. I think this is all we will have to do in our code. So that is all. Excuse that sound. So this is the publish frame, and similarly we'll go ahead and implement something in the client. And in client what we need to do is we need to receive the messages all the time over the topic. So this is the server, and if you want to see whether the server got initialized properly and other things, what we can do is okay, I created the class server, but there is no main in my code. Okay, So let me see in CMake what is there. CMake, we have this, and we have directly server or CPP. Either I need to introduce something as client underscore main and something like that, or let's do it more bad programming, I can say. Why not? I think this should work. I never tried this. I will compile it and see. But if I do here and I start asking for server object, server s broadcast server, and I pass it suppose 5000 and the topic name frame. So is it going to work? I don't know, but it should work ideally. It has a main and it is trying to implement few functions over here. What's the wrong in that? Bad concept, but it's okay. Let's see. Compile output. Undefined reference to server. Yeah, destructor. If I have made the destructor, who will? So yes. My bad. Yeah, this gets me in trouble. Where to put the braces? Sometimes put the braces over here. Oi. Boy, what are you trying to do? Okay, so this is the server, and what we need to do is when we are returning from it, we need to close it. So either I can give a function over here which does this thing, is like it closes the thing. So let's give that function, because that would be better. Close. This handle can be nice for us. So what we do is we implement a close here, and server, if it is going down, it just needs to call close, so that we have a graceful exit. And what we do is we try to just check whether we have the socket alive. If not, so what we do is try, and we just check. And here let's do it in the socket dot handle. So the handle is like the pointer which to the actual thing, so to the actual socket. And if the socket has gone bad or it's gone, so the pointer will be set to null pointer. So the new ZMQ CP wrapper is suggesting always to use that. So let's do it under try, because suppose I have already closed the called the close, and I'm trying to do it again. This would throw some exception. So it would be better if we ZMQ error E. I know we can take a reference over here, and yeah, but this is just a tutorial code. It's not supposed to, go and okay. Let's not bother myself with many things. Okay, so here we have the close and we have everything. So we have a broadcast server, we have over here. And okay, let's do this first. So this is like the signal handlers. And signal handlers, why do I need that signal handlers? Because if I want to sig int what am I doing? Hash include signal hash define bool x app. This is something I use a lot of the time. So to wait, and as well as signal. And here I have this sig int, and I have the signal handler. So I need to create a signal handler which would just go by void sig control C handle the. And what we can do is we can just say int takes will be one component. I'm forgetting. One component would be it takes the signal, and another component which it takes would be nothing actually. Oh, good. Print f and just got signal to exit, and that's all. So what it tries to do is, now it's done, and it will just set this flag app exit to true. And now any while loops which are running, or they can check over your signals, control C, and can go ahead and do their job. So control C handler, obviously the function pointer, and what we do is while app exit, yeah, and we can give a this dot thread std, come on, sleep one. Every second it just checks. Otherwise, since the destructor will be called, we are creating an object, so obviously the close will also be called. In fact, let's try to be shy about this. So let's do one more define f name, and that will go as spd log info and pretty function. I think as name is already defined somewhere, because we will need include frame packer.h. So f name would be coming from them or not? Yeah, f name is here already, so why to bother? So just use it. So it will log the function on entry, and not publish frame will become too much. So this is the logic of server. Broadcast server is there. Now what we need to do is we need to get the OpenCV frames, and then only we can do something with it, right? So we need to actually produce frames. So why let's write a function which is that it produces produce, or very simple, broadcast, I don't know what should be the good name, produce for broadcast, maybe yeah. So let's do this and f name, and what we do here is we try to just produce the frame, serialize it. So capture the frame, then we serialize as pack the frame, and then publish the frame. That's it. And what we need to do is capture the frame, this and this, and we are not going to rewrite this part. We are just going to copy it from our previous source of example, which is in main.cpp. But first we need to trigger this function, and to trigger this function we need to call produce broadcast, and produce broadcast does that, and you'll see why this app exit is very helpful. So if we go, and what we can do is we can actually, I think we should actually trigger this on a separate thread. Or we can do is we can remove this app exit from here and just run a while loop over here. So the call goes inside this function infinitely, waits there until unless a trigger of exit is called, but that would not be something. So it takes this, and it also takes a object. So server star broad server, okay, and what it will do is I can pass the broadcast server, and should it take like that? I have the threading of passing functions. Wow, let's see. We can pass this. We have to do std move on that, I think so. I'm just forgetting. but okay, we'll check on the build. And what we can do over here is where is our main.cpp. So main.cpp test basic video stream, so we capture this. Okay, and what we do is we just edit this piece of code. So f name is already there, and okay, capture, we will keep this thing as it is, sample1.mp4. You can change it as you want, since we are having a very no return kind of stuff, so that's good. Now the app exit is, and what we can do is, if it is exiting from here, we can say app exit equals to true, so that will let the, you know, the below app exit also go away. So this is there, and we don't need cv wait key over here. What we need to do, okay, is just read the frames one by one and move ahead with it. So we can remove it. So what we need to do is return can be done here, but the better thing would be that we first set the app exit equals to true. Okay, so we are going to exit. In any case, if we are done with everything, we are going to exit for sure. So we are going to have a true over here anyway. And while app exit not equals to app exit, yeah, and we can do one more thing over here, which is that we need to loop until the frame count, until the video end is coming. So we can do that. So what we need to do is cap dot, you need to get the property, and which is cv dot current position, something was there, cap prop position frames, zero index of the frame to be decoded next, zero based equals to, if cap is while exit or is not equals to cap dot get cv dot cap prop dot frame count. Yeah, so what happens is that when you are at the end of the video, so you have already reached the position of frame will obviously become equal to the total number of frame counts, and let's, for the safe side, b minus 1. So it will reach to that much. We are skipping just one frame. I am not, count would be 500, and this starts from 0, so maybe this will not hit ever, so the 1 minus 1 would be a good idea. And what we do here is that we are checking whether the position has yet not reached to the end, because if the position reaches to the end, displaying the video is anyway not a good idea, because what is there to display anything. So that's the case. Now first of all, we will try to, so what we are doing here is packing structure and unpack frame. Rather than doing unpack frame, now we are not doing anything over here. We already got the string data, and what we are trying to do is server dot publish frame, and just provide it with the frame str. See, simple as that. So we just provide it with the frame str, and it should actually do the magic of providing the things there. And we don't need to see anything over here. We can just for now see whether our data is all fine or not, the frame which we are doing with. So we can just see the frame or the video for a while. So if I run this, ideally it should go all well. Let's check. Build, save all. Client won't take much time, because we are going to copy a lot of code from here and modify it. Okay, so there are some errors. CPP server.h, msocket.connected. Wow. It gave that error. But was that the error? because that was supposed to be warning. Warning, this is warning, it's not an error. And mhm. Yeah. So what am I missing is I have not yet taken thread library. So if I have not taken the thread library, obviously CMake will say like, hey dude, what are you trying to do? Give me the threads. So because it needs some good threads required. So required means like if you don't have the library, then the building should not go ahead, because the check should fail here and the CMake should in turn fail over here. So what we need to do is now, yeah, thread, and then we need to call, say, the scope and then the library again, and here also we can do the same. This should become case insensitive for lazy guy like me. Okay, so what we do here is this, and I just have one doubt in that passing the pointer towards the thread, because I have stupidly done that, I feel so. This one, but it built. Okay, since it has, why not trigger it once? So let's do a run and see. I see, it should show the video at least. It is publishing over the frame, that's its problem. What? Now what's the problem? Eh? Failed client. But who is running client for now? I'm just trying to run broadcast server. Did I write something stupid here? I might have. Now this looks to be fine. Client.cpp, then server.cpp, frame packer, and this and that. Yeah. And OpenCV libs, and these are there. Now what we need to do is okay. Linking executable client. But what's the case with you guys? Okay, I have more and more questions on this. Okay, so yeah, I got the problem. What problem I did? Stupid one. So what I did was I was not looking at this undefined reference to main. Okay, since the client doesn't have main, the executable doesn't know what to compile actually, which is correct. So what we do is quickly go ahead and main. Yep. Now it should do that. So now the compilation should happen. Control Shift P, and yep, all the builds have happened. So what I need to do for now is just run the broadcast server. So the broadcast server already went with okay. And what is the error? The error is the throwing this invalid argument. And where is it? So broadcast frame 5000, and if we look at once again, the ZMQ already gives us an error. What have we done wrong? Let's debug this one. Do we have the debugging? We can have the debugging. So it's with bind. This is looks correct. What we need to do is create a just checking once again whatever is possible. So we create a context, then we create a socket of it, and then we give a bind argument to it, check for it, and then we are good to go. We are listening because we are connected. So is there anything more than that? No, I don't think so. So server is supposed to do that much, and then this is going to do that. So okay, so what we do is we put a breakpoint over here which tells us whether we are doing this correctly or not. Let's put it to this, and then let's debug it. Dot bind. Okay, server address is not correct. That's what it means to say. Yes, who will give this? Douchebag. Okay, so let's compile this and let's run it once more. Good, good. And if we trigger this, see, we can see the what? Why is there a deserialized? Okay, that is there because excuse me for the sound in the background. Okay, this is because of somewhere here we created a named window, so that named window is being rendered to. So since that is of a different name than this one, so it decided like, oh, so the user needs two windows. I think this would also solve that anomaly, and if we run it, build and run it, I should get my problems fixed and the broadcast should be working fine. And we can quickly jump into, yeah, we are doing this and we don't have any secondary window, and we can see that it is playing, so it must be yeah, obviously you can see here that it is doing the pack frame, so it is trying to throw things over there. Anyway, click on run in terminal because the queue to spd log overflow will kill it, so we don't want to do that. And now what we need to do is do the same thing here but something different. What we need to do is we need to do again the same. So we take a port, and what we take is a std string topic name, and hold on, we'll create a constructor of that. And what we need to do over here is we need to receive frame. So receive frame, and which is just again another function which listens over the socket, receives the frame, and it's up to you how you want to now handle that receiving and play around with it. And then we need to have std string, and what we need to do is create some private member variable which are nothing but one socket and one context. So zmq, so first we need to include the zmq. My typing is pathetic. zmq, message t is not required, socket is required, so socket obviously, and then zmq context is required, and so what we do is context context, yep. And you also need the topic name, so that can be stored as topic, so that is topic. And what we need to do is take the client. I don't know, my voice might be very low in the video. I will come to know after the recording. Okay, I am feeling sleepy, that's the thing, but it's fine. I always feel sleepy. I don't know why I feel always caffeine deprived. I I am sort of addicted actually. Okay, and what we need to do is again call our frame packer, and so first thing we need to do is create the port and context and other things. So we are not going to do that again, just copy it from here. Obviously we are not going to bind here because it is a socket, so what we need to do is connect. We just do connect, and for doing connect, what we need to do is sets, I don't know. I need to check this. Yeah, we can do a connect, that's it. So that's all. And so in the socket T, while we are creating the socket, what we need to do this time would be that we need to set a socket option over here. Like we didn't set that socket option over our server, but in this it would be good if we said let the socket know like what kind of socket you are going to be. So it is done by this. So this is right now ZMQ subscribe, and topic, we can say like on what topic are you going to subscribe on. Topic name dot cstr, and then it's going to be the topic name source site. Okay, and other things looks fine. So we have topic, we have a set socket option done. And now on the receiving message side, what you need to do is you always need to go ahead, and I don't think set socket option is required because obviously you are over here already setting it to be sub. But in the sample code which I prepared for this tutorial, I see that I have used this, and there are codes which are quite old on my on the code side, and I really don't remember what is what for. So sometimes I am just picking few of them from the production code and pasting, or maybe referring them. Okay, so now we have a receive frame. What we need to do is first let's have the common infrastructure, which is let's copy this guy, which will make sure that our while loops can exit if required. Okay, and one more thing is this is the make of that, and then what we need to do over here is take this guy and just attach it here so that any SIGINT which somebody is throwing can be cached, and we need to include the signal.h header. Now this part will be done, and socket client is ready. Not ready now, receive frame, that's the main game. So in the receive frame, what we need to do is we start receiving the message. So for receiving the same thing, you receive the message in a ZMQ message buffer. So first thing is log the function. Okay, good. Obviously this will go quite repeated, but we'll see what we can do. So what I need to do is maybe receive the message on a while loop. That looks okay. So stream, maybe I can do it. Yeah, so what I do is I sit on a while loop, and I can wait for a while, and then again go ahead and receive something, or the ZMQ itself, if the data is there, it will try to forward it to me. So what I will start doing now is that I'll just try while. First let's create the things. So the things are ZMQ message buffer, which is this, and one of them obviously topic name ZMQ message T, and then one of them would be your actual data, which is the payload we are telling it here. So what we now need to do is not app exit, we will capture the data, And once we capture the data, let's have another utility function here called as display frame. So what display frame does for us would be that it would take a CV mat, okay, of or a string, basically string of frame pack, okay, and std string of frame pack, and it does something with it and comes back with the image. So which is going to be too much for, yeah, this will get complicated. Let's not do like that. CV name window and receive frame. Cool. This would be our window name, and let it go for auto size. And what we need to do here is first start catching the data and other things. So we have already declared the payloads and other part. Now what we need to do is go ahead and play with the socket. So first thing we need to do in your socket is socket. Yeah, the topic name, if you are thinking what the topic name would be, the topic name would be your like this is okay. One second, I don't know how to put this into words, but first socket dot you need to do the receive thing, which is very easy. And what you need to do is you need to give a reference to your topic name. So because just like we were doing over there, was first we forwarded our 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 topic, then we put a flag send more, and then we forwarded out uh, the other side. So similarly over here, just do like that. So what we have is like topic name is, this is for just for debugging, and I will silence this line of code immediately after that. Topic name dot data, maybe it will be able to, because it's a character str. Let's see, if not we have to cast it. So that's the thing. So first will come is topic, and then in the second throw we can receive is socket dot receive, and we can receive the payload. So we again pass the reference to the buffer, so that will be populated with our payload. And what we need to do is, now we need to do okay, yeah, there you go. So this is there, and you can give the flag receive flags and none, and similar thing I think over here you can give ZMQ just to maintain the consistency. And okay, you don't have anything here. I thought they would give something over here. So you can do this now. Now you have the message being received and this being received, and socket, why is it showing error? Is it showing error, or is it like okay, ignoring the return value with no discard? Okay, let's have some RC. Now you don't give me the oi. Oh, this one with ZMQ flags, and yeah, ZMQ, take the flag, don't give me warnings, take the flag. No, cool. Now you are done with that, and again it will gonna show you the same thing, like you are receiving without the return code, and that's not good. And what's happening here? Topic name, obviously. Okay, that's done. Now this is done. Now this one is our payload. What we need to do with our payload is we need to unpack it. So the unpacking code can again be picked up from here. So what we do is we have the string already, so we convert it to the string. So for here also dot data would be a bit scary, so why not do it like this? And so our frame pack would become So what we need to do is auto frame pack equals to the payload which is received to string. So this will convert it to the string, and now you need to give it to the frame packer. So what we can do as assertion, but it can do a runtime crash because it's always asserting on that. And if I receive an empty data, boom. So that's done, and frame str will be done. And then what we need to do is show, and we also need to wait. So we do that too. So over here, packer, frame packer, frame packer, frame pack, or frame, yeah, frame str seems to be a better name, str. And we have not created the packer object, so why not create it? So frame packer packer. So this does our case of, you know, and what am I doing? And I copy the cv. Oh, lazy. If cv dot wait key, I just want to wait for 1 millisecond and just see if the guy is pressing q. And then what I need to do is, first of all, why do I need to do anything? I don't need to do anything here. I just need to set my app exit equals to true. Now since app exit is equals to true, here cv dot destroy all windows. Good. And I destroy all the windows and everything. I have not yet written here close, so the close section should be also coming in very soon. And yeah, let's do that fast because I think this video is going quite long, but it's okay. Close the socket. So we close the socket. Let's copy the entire code for close because it's going to be similar thing. Close is close. You have a socket and you want to close it. So that's all. Now we are done with this part, and let's fix the indentation. And receive frame would do this, will show, because I have no, I have just packed the frame but I have yet not taken it into Shivi. I am so that's going to be another task. And for that, unpack frame, why not copy it again, unpack frame, and then here these two are there. Yeah, so less packing structure. Okay, deserialized video, let it be. No, then there will be again two window. Received frame, let's keep it as same. Okay, now I think this should work. What we need to do is now create the client object, client, and what socket are we using here? 5000. So let's give here 5000, and topic name frame, because that should be same. Now what you need to do again after this would be that you need to start receiving the frame. There I created a thread and pass the client object pointer. Here what we will do is we will just call the client.receive frame, because it already has a the while loop, so it's gonna stay there for a while, and once you are exiting it will definitely call the close and it will go away. So first of all, what we need to do is speedy log error, this is there, server started waiting for the frame. I think I should write it somewhere here, server started waiting for the frame. Yeah, because I think over here it is gonna so first receive the topic name, then so spd log info. Okay, server client started waiting for come on for the frame. Okay, this is okay. Now let's first give it a build, because there is lot of things and we want to see whether our build works fine. Compile output. Okay, we have a good build. Now what we need to do is, client started at this is started at this. We can actually, so what I try to do is first go ahead and run in terminal for client and one in terminal for this. Okay, good. What I'm going to do is this time take help of terminal. So terminal here, I'm in the same thing, frame packer repository, and what we're gonna do is cd build and yep. And if we see here, I was trying to do with that. So first we clean the directory and gone. Anything is not there. And now we do this and make -j. Okay. And what we get is getting build. Yeah, frame packer, broadcast, client, and broadcast. All three things are built. Now we have three executables here. So the first one was frame packer, so we are not dealing with that anymore. And what we do is I open the same thing one more here, and I first start the server, which is broadcast server. And we start the client. Okay, I have error with client. I have error with the client. What is the error with the client? What is the error with the client? Once again. Okay, that was a small error here. So what we are seeing is that we got an exception. Server also got an exception. Now client is also getting an exception. Good progress. Now what we do is run, and yep, the exception is here. Did I give something wrong here? Okay, let me check. Obviously I did something wrong over here while writing the connect. So it should be just the proper address, not the entire. Stupid copying, demerits of copying. Yeah. So okay, now if we build it, build client, save all. So should build. So if I trigger client now, hey, still not impressed. It's working fine here. Oh, that's a different directory. This is a different directory. Okay, my bad. Okay. Make -c. Let's build the client again. The client is listing. The broadcast server is coming up, and you can see that you have a received frame over here, and you have a video feed, which is the original frame of the of the server side. So this is good. Now if I scale the server, this received frame is like this. Just the good part is that you see now again, if I start the broadcast server again, this is just like a display corner. So whatever is coming up here will obviously come back down here, and which is flawless. Especially while working with OpenCV, I always in my beginning days faced these problems. And yeah, the control C thing, which you guys want to see. So if I do a control C over here, it catches the signal, and then it tries to do this, and it tries to terminate, and I get a what interrupt system call. I need to see why it is happening. But the point is that you can transfer your OpenCV frames, serialize it properly using this frame packer, where you are using ZMQ, or not ZMQ, Mrs. Pack. And Mrs. Pack is really a very lightweight library. It doesn't have too much of overhead while converting the data. And I know there would be a lot of optimizations which can be done while whatever I'm doing over here, but this was just a sample code to showcase like how can you compress the data, transmit it over the network, receive the data, and re-see all the frames, and you can do your operations over it, and it's all OpenCV back again, because that pipeline sometimes is very crucial. And that is all. This was a simple demonstration to show that. Maybe to see it more properly, what you can do for once is that you don't show this, okay, and you don't show probably this, but I have a feeling that if I silent the CV wait key or the let's see, yeah, it can transmit, not a problem, but we need to rebuild the code. So control save, and we need to make -j once more. So server is being built again, and yeah, we can start the client. There is no changes in client we did. So broadcast server, so you see the received frame area is just coming here. You are having all the data, and it is doing, because the so OpenCV is not respecting the frames. It is seeing it as a just an array of frames presented, because you have not specified any delay. So the FPS looks like very fast, and the video is being covered very fast. One more logic which you can see here, which will work well, is that once the video gets over, you'll see the application exiting properly, and you have to see the birds till then, because the video is about the birds. Yep. There is more actually there. I don't know how long is this. It is probably some 19 minutes long, and I think it is running at around 100 frames per second probably. So with that, I think the 30 frame per second video of 19 minutes gets down to some 3 to 4 minutes. 3 to 4 minutes, yeah, 4, 5. Let's see. I think it's ending. Wait. Let's get done with this. Let's get done with this. I'm bothering you guys to see this video because I want to just demonstrate the exiting part of it, which was written in server while loop. This one, where we are trying to do the position of the frame and frame count -1. Even I have not tested this. I just think it will work, so it would be a good test for both. Yeah, these are good mics. Very good mic. Especially these will be good mic at room, because I can be lazily sounding and it will still capture the voice. I think this video is about microphones, not birds actually. That was a good plot twist. I always thought this video was about birds. Fast man. Yep, it's ending, it's ending. Still not ending. God. Shh. Oi. Ignore the background sound, man. It's ending. I hope I hope it goes to that cam prop and other things. Wow, wow, wow. Yeah, yeah. So our code exited, and that is why this window went blank, because the received frame is receiving nothing. So it went blank. I wait. Now to exit from our application over here, we can do a control C and it will destroy everything. This is what signal handler is for. Okay, so I think that is all from my side on our client. And yeah, but just want to see client close has been invoked or not, called after ZMQ, um, error T. So why there is no client close? Because SPD log is not logging, or our client close is not called? Good mystery. Ideally client close would be called, not called. In this case not called, because I have not made the destructor, so how can the close be called? Okay, okay, bad. What I do is I create a destructor over here and close. Let's do this. So what I do now is that, no, first we make the code. We make the code. We make the binaries. We make the binaries. Oi. No auto saving Qt editor. Bad Qt editor. Fast. It's already okay. Now we have this, and if we run now this, we have a client started and waiting for the frame. If I do a control C, it should still it didn't go on close. Why has it not gone on close? It should go on close now. Client close. I feel now I see out is giving me problem. Let's do this. Close called. SPD log sometimes becomes notorious because obviously it has a separate thread where it takes the data in the sink, and then it has a separate thread for flushing it out into the std out. So that is why it has its own complexities of doing things. Okay, make minus j. Go ahead. Just want to see that the client object is destroyed properly or not. So if I do this, got signal to exit. Yeah, okay, what have I done wrong? App exit equals got signal to exit, that's correct. Printf is printing, then terminate call to throwing an instance of, okay. M socket dot handle not equals to null pointer, close call, M context, then you have this, and then you are doing a try if socket not equals to M context or shutdown. Let's just keep it as this much. Why is it that my close function is not getting hit? Client object would get destroyed after this return 0 getting invoked. So the ideally frame packer and other things are there, then why not close? Terminate called after throwing an instance of this. Why? Client started waiting for the frame, got the signal, terminate called after throwing an instance of this. Where is it calling that part? Okay, 1 second. What I do is I put it on run terminal. Good. Can I debug it? Obviously I can debug it. Just select there. Let's solve this part of the problem and then we are done with the tutorial. because now this is going to eat my hair. hmm And where are we having the terminal for that? Where is the terminal for this? Wait, it's playing games. Come on. This guy is adamant of selling things today. Okay, I am stuck. Run terminal, don't betray me, boy. Okay, good. Show me the place where you fall into problem. Uh-huh. Receive frame. Oh, okay. If I am doing Control C and it is stopped here, okay, so it's all the time waiting over receive C. So it must get out of that because it's waiting on this blocking call. Ow, wow, wow. Okay, I can sort this problem in the next video because this one has already become too big for this video to go. Thank you, that is all. This code will be pushed. Actually, I will push this code right away. Lazy me. Close the terminal, close the things, go here, cd, backpack, git ethos, git add, and what we need to do is just add all this cpp, and we need to add all the star.h, all the headers, and we can add the cmake list.txt. I think git status we can obviously give here path deleted, but deleted, but we never clear. Okay, okay, no problem. Okay, so we are done with this much. Now we need to okay, we need to commit it. Commit minus m zmq pub sub implementation integration machine do frame packer. Okay, that thing could go. Okay, push, and this is all. You'll find the fresh code there, and it has the ZMQ publisher, subscriber, and everything working. So you can use it for your projects if you like it, and you can enjoy. Thank you.